G'day chemistry students, this is our final video on our broad types of chemical reactions, part 3, finishing off dot point 3.1.3. Today we're going to be looking at a set of reactions called precipitation reactions. Let's get into it. So for a precipitation reaction, we generally start with two reactants and we end up with two products. A, B, C, and D are usually, or almost always in this particular type of reaction, different kinds of ions that are able to swap with each other. So if you look at this example over here, we'd have copper sulfate and sodium hydroxide reacting with each other. They could be AB and CD respectively. In both of these examples, they would be aqueous. So copper sulfate dissolved in water and sodium hydroxide dissolved in water. Now, we have two separate solutions, one with copper and sulfate ions, A and B, and one with sodium and hydroxide ions, C and D. Now, what happens is, if we combine them together, we now have A, which could be copper, and D, which could be hydroxide, which haven't actually interacted before. We also have C, which could be sodium, and B, which could be our sulfate, which again have not interacted together before. Just note as well, we don't really care about what A and C are doing because they would both be ions of the same charge. They don't really interact with each other at all. Same goes for B and D, two ions, same charge, that don't interact with each other at all either. What happens over here on our product side is, in a precipitation reaction, we'd be forming a precipitate, where one combination of anion and cation, or positive and negative ion, come together and aren't actually soluble in the solution. And they end up forming a precipitate, a solid at the end. So in our example over here, we have copper sulfate and sodium hydroxide reacting together. They form sodium sulfate and copper hydroxide. The copper hydroxide, usually we don't use a symbol like this, but it's been marked out like that anyway. In this example, usually we would write out our state, so AQ, 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 and this here would be solid, or the precipitate that has formed. Copper hydroxide does not dissolve into water and ends up forming a solid precipitate at the end. Now, I'll look at these examples one by one a little bit later once I've explained a couple of other concepts. I'm going to move over to the next slide before I get into those. Now, in this animation, what I just want to do a quick revision of is how dissolving of an ionic substance sort of works. So here I have sodium chloride. The green is the sodium and the purple is the chlorine. You'll notice that the water comes together and starts to surround the sodium and the chlorine. So usually when the ion exists as a crystal, the positive and negative ions are attracted to each other, and that's sort of what holds them together. But when the water comes along and surrounds it, its positive and negative charges latch onto the ions, noticing that the negative purple chloride ion is being attracted to the white parts of the water, or the parts with the hydrogen that are positive, and the green sodium part is being attracted to the red oxygen end of the water molecule, which has a negative charge. But the idea is the water surrounds it, and there are enough water molecules surrounding to overcome the attractive forces that were holding the sodium and the chlorine particles together. They then separate or dissociate and disperse themselves evenly in a solution. Something that I do want to emphasize, though, is not all ionic substances, such as this one here, sodium chloride, are actually able to dissolve in water. Some are completely insoluble. The forces that bind the ions together are so strong that the water is unable to actually overcome them and make them dissociate in any meaningful way. And so as a result, when we put different combinations of ions together, some are insoluble, they can't be separated by the water, and some are soluble. So we always start with two reactants that were soluble to begin with, two solutions. But when we put them together, we might have a combination of ions that are both soluble. We might have a combination of ions where one is soluble and one is insoluble. And to try and predict what the product that we form is, to predict if there's going to be a precipitation reaction at all, we can use these solubility rules here. So there are a bunch of these. We're going to be using them in practice in class. I'm going to give you a bunch of reactions to do, and you're going to predict whether there's going to be a precipitation or not, and which solid is actually going to form, which chemical is going to be the solid. So I'll do a couple of examples with you really quickly. So copper sulfate and sodium hydroxide are both insoluble. In particular, most sulfates are soluble unless they're one of these guys. Copper sulfate isn't included, so it's soluble. Sodium hydroxide is soluble as well because sodium is a group 1 element, and all group 1 salts are soluble. When we look over here, sodium sulfate, again, is soluble because it has a group 1 element, but copper hydroxide, it says here that most hydroxides are insoluble unless it's a group 1 hydroxide. Copper hydroxide is a transition metal. It's not group 1. It's also not calcium, strontium, or barium either. Therefore, it forms an insoluble salt and will be the one that precipitates out at the end. Similarly, this is a group 1. Most chlorides are soluble. Strontium is not one of the exceptions listed in rule number 3. Sodium chloride is also soluble, again, group 1. But strontium sulfate, if we look, most sulfates are soluble except for strontium sulfate being one of those exceptions. So it is insoluble. It will form a precipitate. Next one, silver nitrate is soluble. Here it says that all acetates and nitrates are soluble, no exceptions. Sodium chloride is soluble as well. It's group 1. Sodium nitrate is group 1 and a nitrate, therefore it's definitely going to be soluble. But silver chloride is going to form a precipitate. Even though most chlorides are soluble, silver chloride is one of those exceptions to the rule, which means that it will form a precipitate. And I think this is our last example. We have cadmium sulfate. It's soluble, like most sulfates are. Cadmium is not one of our exceptions. Potassium sulfide. Potassium is group 1, so it's soluble too. Potassium sulfate, same thing. Potassium is group 1, so it's soluble. But calcium sulfide, most sulfides are insoluble, with the exceptions only being group 1 and ammonia compounds. So cadmium sulfide is not an exception, therefore it will be an insoluble salt and will precipitate out at the end. Thank you very much. In the next video, we're going to be moving on to a different subset of chemical reactions. We're going to be looking at a few different reactions involved with metals. Part 1, I believe, is all about corrosion. But until then, have a good one.